Hey guys, so this is your Monday asynchronous lesson for algebra. This is the last lesson of this chapter, which means next time we are going to be preparing for the Chapter 7 test. So make sure that if you're not sure how to factor, you've reached out to your teacher or have made arrangements to reach out to your teacher to get some help on it. So let's just jump straight into our notes. Take out your paper, your notebook, whatever you're going to be writing this down. Let's title it. This is lesson 7.9b, that's B as in boy, and we're just going to learn anything and everything related to factoring polynomials completely. Learning objective is that we're going to factor polynomials using various methods, so that's just the goal that we're going to keep in the back of our mind is what we're going to focus on. The last strategy that we're going to learn when it comes to factoring is factoring by grouping. Now I put 3 steps here for you to write down, so you'll probably want to pause the video to get that written down and then unpause once you're ready to move on. So factoring by grouping. Well, the first thing we're going to look for, and that's step 1, is if the polynomial has 4 terms. You do want to make sure that whatever polynomial you are given, it is written in standard form. You might as well get that done immediately if it's not written in standard form. That way, it just makes life a lot easier when you're factoring. But once you've identified that there are 4 terms and it's written in standard form, then what we're going to do is kind of group together the terms into pairs. So we are going to take each 4 terms and they take the first 2, kind of group them together, and then we'll take the last 2 and kind of group them together. Then, within each pair, step 2 says factor out a GCF. So what we'll see is that there'll be a GCF with the first 2 terms, and then there'll be a GCF with the second 2 terms. And we'll factor out a GCF within both. It's going to look kind of funky at first. You're going to have, pretty much this giant product of different terms. But what you'll end up seeing is that there's a common binomial factor, binomial meaning it has 2 terms, and when you're able to identify what that is, then you factor that out. In the end, your answer will still look like a product, meaning something being multiplied, of binomials, so something that has 2 terms. In the end, it'll look like our answers that we've seen before in the last few sections. Just takes a few more work. And a few more steps. I like to think of factoring by grouping kind of like those Russian dolls, like where there's one inside the other. And that's really what factoring by grouping is. It's like you're starting with the big Russian doll and you open it up and then there's another. That's like a GCF. So then you take out that little doll and then wait, there's some more. And then, excuse me, then you factor it out again. So that's just a way I kind of think about it, but let's just see what it looks like in actual math. Now, for later on in this lesson, I will show my way of factoring. And I know Mr. Sansoni's class, you may not have learned the way I taught factoring, so you can just factor the way that makes sense for you when we get there. But let's jump into factoring by grouping. We have this polynomial, x cubed plus 3x squared plus 2x plus 6. So I see we have 4 terms. I know this is written in standard form already because from left to right, the exponents on our terms go from big to small. So there's nothing I have to kind of rearrange or rewrite. So that means I can just move on to grouping them together, grouping them into pairs. 4 terms mean a pair of 2. So I like to use brackets. So I'm going to put a little bracket on the bottom between x cubed and 3x squared. That's a pair. And another bracket around the other terms, 2x and plus 6. It's like too many problems in one. Within our first pair, x cubed plus 3x, or 3x squared, excuse me, I'm going to look for a GCF. Well, remember, a GCF could be a number, it could be a variable, or it could be a product of a number and a variable. If your GCF includes a variable, well, that would mean that all the terms have a variable, meaning a letter. It has to be the same one. And I see that both my terms in this first pair have an x. That means x of some sort will be part of my GCF. So I like to start by labeling it. And I'm just trying to be very clear about what my GCF is going to be. Well, I know it's going to be a variable. I know it's going to be x. Now what matters is what the exponent on my GCF will be. Well, in this case, it's always the exponent of the smallest variable term. So we are comparing x cubed and x squared. The smallest exponent is x squared, meaning x squared is my GCF. So when I factor out a GCF, I'm going to show my work inside these parentheses. What happens is I'm technically dividing out x squared from each of these terms. So I have x cubed divided by x squared plus 3x squared divided by x squared. Now I can continue right now and I can finish simplifying, but I'm going to hold off for just a moment to work on that second pair of terms, that 2x plus 6. I'll do all of my simplifying at once. So pretending like x cubed plus 3x squared isn't there, I'm going to look at 2x plus 6, and I'm going to look for, within that pair of terms, is there a GCF? So again, our GCF goes on the outside of parentheses, and I'm just being extremely clear by labeling what a GCF is. I see that only one term has a variable, meaning an x or the variable is not going to be part of our GCF. So then I look for the numbers. I look for, and maybe there's a number that both terms have in common. And that's when I'm looking at the coefficient of 2 and our constant of 6. Well, just given those two numbers, there is a GCF. The greatest common factor between those two numbers is 2. So that means I could divide out a 2. So I'm going to show that work. I'm going to prep it inside. When I factor out a GCF, I'm dividing it from every term. So I'm doing 2x divided by 2 plus 6 divided by 2. From here, I will actually do all my simplifying. So starting here on the left with my green pairs, I still have a GCF of x squared hanging out. When I simplify inside, x cubed divided by x squared, that's just an x. Then I still have a positive, I still have a plus. 3x squared divided by x squared, well, those x squares cancel out and it leaves you just a 3. So right now I have x squared times x plus 3. Cool. Now I'm going to move on to what's in pink. And I'm going to show this work and simplify that out. Now I still have my GCF of 2 hanging out. Now this was a positive 2 that I factored out, so I'm just going to be clear and put a little plus sign here to show this was a positive 2 that I had factored out. Simplifying inside those parentheses above would be dividing out 2, and 2x divided by 2, that's just x. And 6 divided by 2 is a positive 3. Now we're looking for what is the common binomial term, which really is just what's in parentheses. Notice in the green, and I'm going to highlight this, in parentheses we have the expression x plus 3. But we also have that exact same expression in pink. It's also an x plus 3. That means we have another GCF. So if I kind of prep this again, I have another GCF. The common factor between what's written in green and what's written in pink is the expression x plus 3. So I am going to divide that out. That's technically what factoring out means. I'm going to divide it out from everything. So what is that going to look like? Well, it's going to look real gross for a minute. But it'll be okay, I promise. So I take x squared times x plus 3, and I'm technically dividing out x plus 3. Plus 2 times x plus 3 divided by x plus 3. Now what's happening here is that both the x plus 3 on the top part of my fractions is the exact same thing in the bottom. they cancel each other out. That's what really factoring allows us to do. It's what's dividing it out and canceling it out. So these all go away. And it leaves me with just this expression of x plus 3 on the outside. And what's left on the inside of these big old parentheses is x squared plus 2. And this is my final answer. It was a lot of work to get there, but it's because it's showing a lot of steps and there's a lot of explanation that goes along with this. But my answer is still a product of binomials. And that is what I get. That is what this polynomial comes out to be. Let's try another one. Now I have an A and a B and a C that I'm still going to walk you through before I will let you try some on your own. Let's try B. Well, that looks gross. There's just a lot of letters. There's a lot of variables here. But it's okay. We can still figure this out. It might have a hard time rewriting this expression into standard form. And that's okay. You know, it takes time to be able to figure that out when it's only variables. But when you're only having variables, you want to try to rewrite or group your, how do you say this, the common terms, the terms that have like the same variables, you want to try and group those together. So right now I have x squared plus y plus x plus the product of x times y. Well, in order to factor by grouping, we need to make sure that I can have things together that are going to work out. And right now, this just looks like a bunch of letters. So I'm going to try and group like the terms that have the x more on the left side of my expression and terms that have a y more on the right side. So x squared is already first. So I'm just going to look at these other terms. I see I have an x here and an x in this product. But I also see at that product there is a variable y and there's just a lonesome y. So I think it'd be easier just to flip-flop the plus x and the plus y. And I can do that because they're positive and it just really means we're adding, and addition has a commutative property to it. That means you can add numbers in whatever order you want and you still get the same answer. So I'm going to rewrite this that I have. So I have x squared, now plus an x, plus a y, plus x times y. Notice now that if I try to group things together, I can make a group that has a common variable of x, and I can make a group that has a common variable of y. And that is what I want. I want to be able to group things together in order to find a GCF, or a greatest common factor. So let's take our first grouping of just x. I'm going to be extremely clear again and say, what is our GCF? Our GCF, in this case, is only a variable, and it's only an x. So let me show this work inside my parentheses. When I factor out a GCF, I'm dividing by an x, technically, in each term. Now let's look at our second pair, the ones that have some y's. Again, there's only a variable as our GCF because I see no numbers. And they both have a y in common. So I'm going to put a y on the outside as my GCF. And on the inside, I'm dividing everything by y. This y, still a positive y, so I'll still be very clear and put a little plus sign to show this was a positive y I factored out. Now let's simplify inside all these parentheses. Starting with the pink expression on the left. I still have an x on the outside. Inside, x squared divided by x, that's just x, plus x divided by x. A lot of people get confused with this, and sometimes they say it's 0. Sometimes they just stop. It's the same variable on top as it is on bottom. That's one whole. If I asked you what's 2 divided by 2, hopefully you would know that that is a 1. If I said what's 4 divided by 4, you should hopefully say that is 1. It is one whole. You have the same number on top as you do on bottom. And it applies the same way if it's a variable. If you have the same variable in the top part of your fraction and the same variable on the bottom, that's 1. It's one whole. They're canceling themselves out to be 1. Now let's simplify what the expression on the right that's written in blue is when we had the GCF of a y. So I still have plus y technically here on the outside. If I simplify inside, y divided by y is 1. xy divided by y is just x, because the two y's will cancel themselves out. So now I have this expression of x plus 1, or x times x plus 1, plus y times 1 plus x. Well, what's inside the parentheses looks almost exactly the same. And well, they are actually exactly the same because they both are an x plus 1. Yes, what's written in blue, it is backward, so meaning the constant went first and then the variable went second. But it's the same exact expression. Why? Addition is commutative, meaning I could rewrite this to make this look a little bit nicer. So I have a whole new problem looking of x times x plus 1 plus y times x plus 1. Addition is commutative. I could rearrange the 1 plus x to be x plus 1 and it would still be the same expression. Now it looks a little more familiar. What I see is that inside the parentheses, they have the same thing, the same binomial. So that means I can factor that out as my GCF. I'll show the weird looking work here inside. Technically, when you factor out a GCF, what happens is you're dividing it out from every term. So that's the work I'm starting to show. And it looks really gross, but it simplifies out perfectly because inside these big, ugly looking parentheses with all these x plus 1s, I have the same expressions on top as I do on bottom, which means I can cancel them out. And all that's left inside those parentheses is x plus y. And so this is actually our final answer, is the product of x plus 1 times x plus y. Some of you might be noticing that the other binomial term is really just what's in front of these parentheses. And if you're able to see that, then you might be able to get to your final step a little bit faster. And if you can't, it's not a big deal, because we can still do everything we need to, the same long steps to get to the same final answer. This is the last one I'll do for you before we move on to some that you will try. I'll probably get you started on this one. So I'll start you off helping you with rewriting this into standard form, and then I want you to pause and I want you to try this problem on your own. We have x cubed minus 7 minus x squared plus 7x. Well, now this looks a little more familiar. This looks like a more common binomial or polynomial that we've seen in our lives at some point. What I notice is that this is not in standard form, meaning from left to right, my exponent of the terms do not go from big to small, so I need to do a little rearranging. So I'm going to keep the term that has the largest exponent, and that's the x cubed. That stays. The next smallest exponent is the x squared. So that means minus x squared goes next. The next smallest is just the 7x because it actually has an exponent of 1. So I rewrite plus 7x. The constant, the normal number, always goes at the end. Now I want you to try factoring by grouping and see how it works out for you. Please pause now and unpause when you're ready to check your work. All right, let's see how you did. So we should have grouped the first two and the last two terms. Within the first two terms, the GCF is x squared. When you factor that out, you would be left with x minus 1. Looking at your second pair, the GCF was a 7, and it was actually going to be a positive 7, so I'm going to put a little plus sign. And when you factor that out, you'd be left with x minus 1. From here, you should be able to tell that inside the parentheses, they both have x minus 1, meaning that is another little GCF that gets pulled out here in front. And what's left after you go through full simplifying is the expression x squared plus 7. How'd you do? Did you do okay? Did you figure it out? Did you run into any issues? Well, let's see. I didn't show all the nasty details on this one. So try and check your work with it. See, did you get it? Did you not? If you didn't, it's not a big deal. We still have more to practice. This one is all you. No help, nothing. This is example 2A. Try this one 100% on your own. Then unpause when you're ready to check your answer. Okay, let's see how this went. So in this one, some of you might have wanted to combine the 5x and the 2x. And then you can factor it another way, but I really, really hope you didn't, because we are trying to practice our factoring by grouping. Because it has, right now, it just has 4 terms. I'm going to keep it as 4 terms. And I would have grouped together the first 2 and grouped together the last 2. Within the first pair, the GCF is actually a variable, and it's just x. And when you divide x and x squared, you are left with just an x. When you divide 5x and x, you're left with a positive 5. With the last pair, this actually only has a GCF of a number. Between 2 and 10, the GCF is a 2. It's actually a positive 2, so I'm going to put a little plus sign in front of my 2. If I divide 2 with 2x, I'm just left with x. If I divide 10 and 2, we get 5. Hopefully you're seeing right now, or you did see on the first try, that inside these parentheses, they both have the expression x plus 5 in common. So then I pull that out. That goes in front. And I have an x plus 5 times what's left over is x plus 2. So your final answer in this one should be x plus 5 times x plus 2. Now we didn't have to do a factoring by grouping on this one. Technically, I could have combined my like terms and had x squared plus 7x plus 10, and you could actually factor that trinomial into the exact same product. That was just a coincidence. It does not always work out. Okay, let's move on to the next part of our lesson, which is called factoring completely. Well, factoring completely is where we need to end up being comfortable with, because at this point in time now you've learned every possible option when it comes to factoring. And when we'll be moving on to these other chapters and in the rest of this year, is in order to solve any of those other problems we're going to see, you have to be able to factor completely. Meaning you have to break down a polynomial to be as small as possible into as many factors as possible. So when we factor completely, this just means you start with what we learned with the beginning of this chapter, which was find a GCF. If you can find a GCF, you factor it out. You will be left with, most likely, some kind of trinomial, meaning something that has 3 terms. Then you use whatever factoring method you learned from there to factor it even further. So let's just see what's happening here. Example 3a, we have 3x cubed minus 18x squared plus 24x. So I see I have 3 terms, okay? So I need to start with, is there a GCF? Is there a greatest common factor between all 3 terms? I will be extremely clear for right now and label out what is my GCF. I notice that all 3 terms have a variable, meaning a variable is going to be part of my GCF. The variable they have in common is x, and it's just going to be a normal x because you look at what's the exponent of the smallest variable, and that's just this normal x right here. Technically has an exponent of 1. That means the variable x is what they all have in common. Now let's compare the numbers. We have coefficients of 3, 18, and 24. The GCF, the greatest common factor between those three numbers, is 3. That means my GCF is actually the product 3x. So let me factor that out. Let me divide that out. I'm going to take 3x and divide it by 3x cubed. I'm going to divide 3x by the negative 18x squared. And I'm going to divide it by the 24x as well. Well, I'm going to keep going. I still have my GCF on the outside. I'm now going to drop the label. Simplifying inside my parentheses. The 3 and the 3, they cancel. X cubed divided by x, that's just x squared. Moving on to the next term. Negative 18 divided by 3 is negative 6. And then x squared divided by x, that's just x. And our last one, we are going to just work with the numbers first. 24 divided by 3, well, that's 8. And those x's cancel. So now, inside these parentheses, I still have a trinomial. I still have something that has 3 terms. So I need to try to figure out, can I break this down even further? Can I break down x squared minus 6x plus 8? Right here. If you were in Mr. Sansoni's class, I know he taught you a different method that what I'm going to show when it comes to factoring. You factor however you feel comfortable. So inside these parentheses, we have the polynomial x squared minus 6x plus 8. Factor that however you learned it. For my class, you know I personally like the x box, so I'm going to show that. Inside the parentheses only. The top part of my x is a times c, which is 8. Bottom part is b, which is negative 6. I think about what times what gets me 8, but adds to a negative 6. Well, if something's multiplying to a positive number, but adding to a negative, that means both options have to be negative. And that only leaves me with negative 4 and negative 2. I'm actually going to switch places. I'm going to put negative 2 here, then negative 4. And then from there, I'm going to fill in my box. Top part of my box is x squared. Bottom right of my box is the constant 8. Bottom left is negative 2x. Top right is negative 4x. Then for me, I'm going to factor out. X times x is x squared. X times negative 2 is negative 2x. X times negative 4 is negative 4x. That means that this polynomial, x squared minus 6x plus 8, comes out to be x minus 4 times x minus 2. But this GCF, this 3x that I kind of just ignored, it's still there. So there still is 3x in front of everything. I just now have broken this down into multiple sets of parentheses. So I have an x minus 4 and an x minus 2. This right here is what it means to factor completely. I factored out GCF if I could, and then I broke my polynomial down even further to just be its original factors. I can't do anything else. So I stop. This is my answer. It is a big old product. That sounds confusing. Well, it just takes a lot of practice. And we have plenty of those problems. Let's try B. Now I do have my own set of problems for you to try. These are still some I'm just going to walk you through. So we have 7x to the 4th minus 28x squared. So first thing you do is check, is there a GCF? Is there a greatest common factor? Now again, I will be extremely clear when I label this. I see both terms have a variable, which means a variable is part of my GCF. I then look for what is the variable that has the smallest exponent. that is x squared. That means x squared is part of my GCF. I then look for, do they have a common number? Do they have a common coefficient? And between 7 and 28, their GCF is 7. That means that is also part of my GCF. Let me show the work. I factor out a 7x squared, which means I'm technically dividing it out from every term. Well, let's see, what does that look like now? Let me rewrite this. I am going to drop my label of GCF. I have 7x squared on the outside of parentheses, and inside, the 7's cancel. X to the 4th divided by x squared, well, it's just x squared. Minus 28 divided by 7, negative 28 divided by 7 is negative 4, and the x squareds cancel. Okay, well, inside these parentheses, I have x squared minus 4. You need to try to factor that. Now, you may not feel comfortable doing what I'm about to do, and if you don't, you can factor x squared minus 4 using any method that you've learned. I can immediately recognize that x squared minus 4 is a special product. You guys learned that at the end of last week. This is a difference of squares, meaning this formula, if you will, a squared minus b squared, factors out to be a plus b times a minus b. So I know by using this formula, just because I've been doing this for a long time, that factoring out x squared minus 4, it should give me the final answer with the GCF still out front of 7x squared times x minus 2 times x plus 2. Well, you might be like, Ms. Horner, I've been doing this for like 2 minutes and I didn't know that. So how do I do it if I don't know that? Well, let's factor x squared minus 4 using some of our other methods. Now, if you're in my class, you know, again, I'm using Xbox. If you're in Mr. Sansoni's, factor that however you learned. Now, when I use my x here, I'm doing a times c, meaning the coefficient in front of x squared and the constant, which is negative 4. But my b term is missing. B term in a polynomial is the number in front of just the x, and there is no x alone inside those parentheses. It's actually a 0. And so now you're thinking about, well, what times what multiplies to negative 4, but cancels out when it gets added. It adds to 0. And your only options there are negative 2 and positive 2. So then when you go into your box and you fill in what you can, you'd have x squared in the top left corner and minus 4 in the bottom right corner. The information from my x gets filled in the remaining boxes. And when you work outward, you'd have x times x, and then x times negative 2, and x times positive 2. So in the end, I'm still getting the exact same answer of that expression that I put in the box. So whether you can recognize the formula or you use any other method, you should get the exact same answer. Ooh, let's try this one. Let's try C. And I know this is a long lesson. I am sorry. It's just how it works out. Okay, so right now we have C, and this is the last one I'll do for you before I let you try some. We have p squared plus 4p minus 2. Okay, so first thing I have to do is try to figure out, is there a GCF? Is there a greatest common factor? Okay, well, I do not see a variable in every term, so the letter P is not going to be a GCF. Now let me think about, is there a number? Maybe there's a number they all have in common. Well, in front of p squared, there's technically a coefficient of 1. So if I compare 1, 4, and 2, there's actually no GCF between those, meaning there's not a GCF. I can't factor that out. And that's okay. You come across that sometimes, which means you just move on to however you learned how to factor. Try to factor this out. Let's see what's going to happen. You guys know from my class I'm using the X box. So I'd have A times C, which is -2, B is 4. Okay, well, I'm trying to think about this. I'm trying to find two numbers that multiply to a -2, but add to a +4, and I'm out of loss. Because -2, the only options I have would be a -1 and a +2, or a +2, or sorry, -2 and a +1. And if I add any of those factors, -1 plus 2 is a 1, -2 plus 1 is -1. Neither of those work. That is not getting me what I want. And there's no other option, which means this is not factorable. And your answer is literally the problem, because I can't break it down anymore. Now, we are going to learn eventually in Chapter 9 a method how to work with these, but for now, this isn't factorable for us, and we just leave it as is and move on with our lives. Sometimes that happens. It's weird. All right, I want you to try your own. Then I promise we only have one little set of problems left, and then we'll be done. So try this all on your own. Factor it completely. Pause it when you're ready. Unpause to check your answers. Okay, so you've had some time to work on it. Let's see what happened. First one, 2x cubed minus 2x squared minus 12x. I see there's a variable in common, so I know GCF is going to have a variable. Between the coefficients, I see they also have a 2 in common. So 2x will be part of my GCF. I'm going to factor it out, meaning I'm going to divide it out. So I'll show that work. And this all simplifies out to be 2x times, inside my parentheses, the 2's cancel out. X cubed divided by x is actually x squared. 2's cancel out. X squared divided by x, still a -x. -12 divided by 2 is -6, and the x's cancel out. So now I am left with a trinomial, which I need to try to break down even further using whatever method I know. So for my class, it's the X box. Top of my X is A times C, which is -6. Bottom is B, which is -1. And I'm thinking about what times what multiplies to -6, but adds to a -1. Well, the only things I can think of are -3 and a +2. Those multiply to a negative number, but add to a -1. So that's perfect. I go over to my little box here. I fill in what I can. Top left is x squared. Bottom right is -6. Bottom left is -3x. Top right is 2x. Working outward, I'd have x times x, then x times -3 is what gives me -3x, and x times +2 is what gives me a +2x. So I can write my final answer with the GCF still in front of the factors x plus 2 times x minus 3. Now, I did forget to mention earlier that maybe if you had some factors switched around, meaning you say on this example, you'd have x minus 3 and then you'd have x plus 2, that's actually the exact same answer because multiplication is commutative, meaning I can multiply in whatever order I want and I'd get the same answer. Let's see how you did on B. On B, I see that they probably only have a number in common because they don't both have a variable. So I just became comparing 2 and 18, and they have a 2 as a GCF. When you factor out a 2, which is really divide it from every term, you'd end up having 2 times x squared, because the 2 cancel, minus 9. Well, I can recognize right off the bat that this is a difference of squares, so I know my final answer should look like 2 times x plus 3 times x minus 3. Or those could be switched around. You could have an x minus 3 first, then you could have an x plus 3. Something like that. But, just in case you want to see the other method, if I didn't know my formulas, I didn't recognize this is a special polynomial, I can use whatever method I know to factor x squared minus 9. So if I use my x box, I'd have a times c, which is negative 9, and there is no middle term. There is no b term, so there's a 0. And you'd think what times what multiplies to negative 9, but adds to 0, and that's positive 3 and negative 3. So that when you would fill in your box, you'd have x squared in the top left, negative 9 in the bottom right, 3x bottom left, negative 3 top right. Working outward, you would have found that you had x times x is x squared, x times positive 3 is 3x, and x times negative 3 is negative 3x. So no matter what, you should still get the same answer I had boxed in blue. All right, swear we're almost done. We are now in the last part of our lesson, and it's a preview of where we're going to go into soon. And it's actually solving polynomial equations. So I wrote down the 3 little steps. Again, this is a preview. You don't actually have homework on this part, but this is a preview to where we're going in our algebra lives. I would pause the video to write down those 3 steps. Okay, so to solve an equation when it comes to a polynomial, the first thing you have to do is set the equation equal to 0. Then factor that one side completely. What you'll be left with is 2 factors all set equal to 0, which is actually section 7.5, which is the zero product property. And you pull the 2 factors apart, set them equal to 0, and solve for the variable. Well, let's see how this works. I have 2x cubed plus 8x squared equals 10x. This is an equation. Following my steps say set it equal to 0, meaning I'm moving everything to one side of my equation. I am personally going to move the 10x to the left because it's the easiest. It's what's going to get me to one side equaling 0 the fastest. And in order to do that, I subtract 10x on both sides. This leaves me with 2x cubed plus 8x squared minus 10x equals 0. Check that box. We've said equal to 0. Step 2 is factoring completely, meaning on the left side of my equation, I am going to factor this out as much as physically possible. So using our strategies from above, from those previous examples, we're going to find our GCF. This will have both a number and a variable. The number they all have in common is a 2. The variable they have in common is x. If I factor this out, I have 2x cubed divided by 2x plus 8x squared divided by 2x minus 10x divided by 2x, still equaling 0. Still have 2x hanging out, but let's simplify inside the parentheses. The 2's cancel. X cubed divided by x is actually x squared. 8 divided by 2 is a positive 4. X squared divided by x, that's just x. Negative 10 divided by 2 is negative 5, and the x's cancel out. This still equals 0. I still have a trinomial inside my parentheses, so I am going to factor it even further. So I'm going to use my x box on the inside here. A times c is negative 5, b is 4. What multiplies to negative 5 but adds to a positive 4? It's a positive 5 and a negative 1. Filling in my x, I'd have x squared in the top left, negative 5 in the bottom right, and I'd have x times x is x squared. X times, fill in the rest of my box here. X times positive 5 is 5x, and x times negative 1 is negative x. Gonna keep going, because I have to rewrite my problem. I now have 2x times x minus 1 times x plus 5, still all equal to 0. Ugh, gross, this never ends. Well, this is a zero product property. I have factors that are being multiplied and they equal 0. So I have 3 mini problems where I take each factor, set it equal to 0, and solve for x. So my first problem is 2x equals 0. My second problem is x minus 1 equals 0. And my third is x plus 5 equals 0. Starting here on the left, 2x equals 0. To get x by itself, you divide. So I divide by 2, and I'd get x equals 0. The middle problem, to get x by itself, you add 1, and you get x equals positive 1. The last problem, to get x by itself, you subtract 5. So we get x equals negative 5. So when you're solving an actual equation with polynomials, your goal is to figure out what are the x values. And in this case, we have 3 of them. X equals 0, x equals 1, and x equals negative 5. I know that was a lot, and we're just going to kind of stop here. I was going to do another problem, but that's a long lesson. So take a breather for a moment, but you all have homework, whether you're in my class or Mr. Sansoni's class. It is on Delta Math. You do have 2 parts to it. First part, you need 10 questions in a row correct. Second part, you need 5 questions in a row correct. There are no questions asking you to solve, just to practice factoring by grouping and factoring completely. Reach out to your teachers for more help for anything that you need, and I hope you have a good one.